Hello, welcome to my physics kinematics video. This is going to be following the introduction, so if you haven't seen the first video, you definitely should because I'll be moving a little bit faster and things will be a little bit different on this example. But we were going over our equations in the first video and how to apply them to whatever problem you may have. In this case, we kind of have the same problem as we did in the first example, except we have a boy throwing the stone downwards with an initial velocity of 5 meters per second. Again, it wants to find the time that the stone reaches the ground. We also do have the same displacement, so that still is the same. So let's go ahead and find our variables. Our initial distance we have is 250 meters because this boy is 250 meters up higher than the ground. So initial distance is 250. Our final distance is at 0 because the stone lands on the ground and that's 0 meters high. Okay, so then we have that tells us that the boy throws a stone downwards with an initial velocity of 5 meters per second. Now be really careful when you read the problem. It says downwards. He throws the stone downwards. So the initial velocity is not going to be positive. It's actually going to be negative. So our initial velocity is negative 5 meters per second. I'm not going to write the labeling because we pretty much know now what V stands for, what X stands for. Next, we have to find the acceleration. It's not a given to us, but once again, since the stone is in free fall, we know that the acceleration is going to be negative 9.8 meters per second squared. And the only thing that they haven't given to us is, aside from the time, which they want us to find, of course, but the only thing that they haven't given to us is our velocity final. So once again, like the first example, we don't have our final velocity. So we're going to scroll down here and we can see that if our distance is not given, we use this formula, so on and so forth. Well, in this case, we don't have our final velocity, so we're going to go ahead and use this formula right here. So let me go ahead and just copy paste this formula. Okay. And once again, we're looking for the time it takes for the stone to reach the ground. So now the only thing we have to do is go ahead and plug in for our variables. Our x is 0 because that's our final distance that it reaches. Our initial distance is 250 meters. That is my phone ringing. It's probably just telemarketers. Alright, so we have 0 minus 250 equals our initial velocity, and I put an I here, but the O and the I, you can use them interchangeably. So our initial velocity is negative 5, and we're going to keep the t on there since that's what we're solving for, plus 1/2 of our acceleration, which is negative 9.8, times our t squared. And let's just go ahead and really quickly simplify this. We get negative 250 equals negative 5t minus 4.9 t squared. Alright, and if you haven't noticed already, yes, that is 2, that's horrible too. Okay, if you haven't noticed already, it looks like we're going to have to use the quadratic formula for this problem because we're solving with a t and a t squared. We can't really solve for that unless we use a quadratic formula. So what we can do is go ahead and move everything to one side and have everything equal to 0 and then find our a, b, and c. What I usually like to do is have anything that we're squaring and putting under the square root be positive. In this case, I'm just going to move the negative 5t and the negative 4.9t squared to the left, and then just have this equal 0. So when I do that, the 5t and the 4.9t squared will be positive, and that way I can just have everything be equal to a, b, and c, since we always want to make this a, this b, and this c with the constant without any variables. So let's go ahead. We're going to get 4.9 t squared plus 5t minus 250 equals 0. And we're going to want to use the quadratic formula to go ahead and solve for the t. So if you don't know the quadratic formula, it is, let me just go ahead and write it up here. It is x equals negative b plus or minus b squared, and this is all in square root. It'll be b squared minus 4ac, and then that's all divided by the 2a. It's really sloppy, but that's fine. And again, like we said, this is going to be a, this will be b, and this will be c. When you plug in your variables in here, I'm not going to do the calculation because it'll take a while. I don't want it to go over the limit, and I don't want to bore you guys. But when you do the calculation, since you're doing a plus and a minus, of course, anytime you do the quadratic formula, you'll get two answers. In this case, I got t equals 6.65 seconds when I added them. And then when I subtracted from, I got t equals negative 7.67. So right now, if you're like, oh no, which one do we use? The time is never going to be negative. It's always going to be the positive number. So for sure, your time is going to be this one right here. And that's if you have to use a quadratic formula, your time will always be positive. So our time that it takes for this stone to be thrown to the ground with an initial downward velocity of 5 meters per second, it'll take 6.65 seconds. So like we expected, with the last problem took a little bit longer since the initial velocity was at 0. In this problem, the initial velocity is not 0, it's 5, so it takes a little bit less time to throw that stone and for it to reach the ground. So there you go, you found your answer. And our next problem that we're going to do will be the kinematics in 2 dimensions.